Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. It is 6.1, Graphing Radical Functions. Radical function. The radical parent function is f of x equals the square root of x. This is going to be very similar to the last unit we just did, where we're going to use the parent function. It's going to look the same every single time. We're just going to move it around a little bit, and we might stretch it just a little bit. Okay? So in order to graph our parent function, what we're going to do is take each one of these x values and plug them in for our x. So for x is 0, it would be the square root of 0, which is in fact 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. Okay? If I go ahead and plot all those points, I will have 0, 0, 1, 1. It'll be 4, 2, so that's 2, 3, 4, 2, and 5, 6, 7, 8, 9, 3. If I can connect those, notice I have a little bit of a curve going up to the right. Okay? That is what my parent function will look like. Just like our previous unit, our parent function looked one way. On almost every single one of our graphs, our parent function is going to look the same. I'm just going to move my parent function around. All right, but now I need to figure out my domain and range. This is going to be a little different than our previous unit. Notice that the starting point right here is 0, 0. Okay? Since it is 0, 0, that means all of the numbers of x that are in my graph will be to the right of 0, correct? So that means they're all positive x numbers in this case. So my domain is x is greater than or equal to my starting point, which is 0. Then my range is going to be the same thing. It's going up. So as it's going up to the right, all of my y's will be larger than the starting point. So y is greater than or equal to 0 as well. Okay? Next says, just as with the rational functions, there can be transformations with radical functions. So we have f of x equals a times x minus h, or times the square root of x minus h, and then plus k. So a transformation caused by a is what is known as a stretch. It is a stretch by the factor of a. So when a is greater than 1, it will stretch. And when a is less than 0, or when a is a negative number, it will reflect over the x-axis. You can really think of the negative sign and the a as being two separate things. They're still going to do the same thing whether it's positive or negative as far as the a stretching our graph. You'll see that here in 1 second. And then the negative, no matter what my a value is, the negative is going to reflect it over the x-axis, and I'll show you what that means in 1 second as well. The transformation caused by h, it's the same idea as our last unit, where if it was underneath of the fraction bar, then we're going to move right or left. So it is a horizontal translation. And again, we are not going to follow the sign of anything that is underneath our square root. The transformation caused by k, which is outside of our square root, is going to be a vertical translation. So as far as our h and our k go, it's going to be exactly the same as our previous unit. So now we need to look at number 1. What I need to talk about is all of the different transformations that have occurred. So since 2 is my a value, it's in front of the square root. That's the first thing I come to. 2 is going to stretch our graph by a factor of 2. Okay? That's the first thing I ran into. So now that I'm to the square root sign, I'm going to look for any number that is underneath the square root sign. Well, in this case, I have a -1. So it's going to be a horizontal translation. Just like with our rational functions, if it's underneath of the square root sign, then I'm going to go opposite the sign. So since this is negative, this tells me that I'm going to go right 1. There is not a vertical translation because there is nothing on the outside of our square root over here. Now, to fill in our graph, this is going to be a tad bit different. I'm only going to use everything from the x and forward. So I'm going to rewrite my equation on top of my table as y equals 2 times the square root of x. I only need to solve that equation to fill out my table. But if you remember from up here, I use 0, 1, 4, and 9. The reason why I choose 0, 1, 4, and 9 every single time with a square root function is because those are really, really easy to take the square root of. So every single time that I have a square root function, I'm going to use 0, 1, 4, and 9 to fill in my x values. So now if I take 0 and plug it in for x, I end up with the square root of 0, which is 0, times 2, which is also 0. Then I need to plug 1 in for x. Well, the square root of 1 is 1, times 2 will be 2. Now I'm going to look at the square root of 4. Well, the square root of 4 is 2. 2 times 2 would be 4. And then I put 9 in for x, so the square root of 9 is 3. 3 times 2 will get me 6. So I can go ahead and plot those points, but I'm not going to make my line yet. I'll tell you why here in 1 second. So we have 0, 0, then I go 1, 2, then I go 4, 4, and I go 9, 6. Okay? I do not want to make a solid line here because we still haven't talked about our horizontal translation right 1. So what I'm going to do is make a dotted line that shows where my graph is from my table. Now I can move my graph whatever my horizontal or vertical translation tells me to move it to. So I'm actually going to change colors here so it's easier to see. So I'm going to take all these points and move them to the right one. Because I had a horizontal translation right 1, now I can make a solid line, and that is my actual graph. That is the graph that solves our equation. Okay? So now I have to figure out my domain and range. So I want to find the value or the coordinates of that point. It's 1, 0. So my domain will be x is greater than or equal to 1. My y would be y is greater than or equal to 0. That works when I go up and to the right. It's always going to be greater than or equal to if it's up and to the right. Okay? Let's go ahead and move to number 2. It's on the back. So I have f of x equals the square root of x minus 2 plus 3. I do not have any numbers or a negative in front of my square root sign, so I will not have a stretch or a reflection. But I do have a number underneath my square root sign, so it's a horizontal translation. I'm going to go opposite the sign, so I'm going to go right 2. And now I do have a number on the outside of my square root sign, that's this positive 3. So I do have a vertical translation, up 3. Remember, to fill in my table, I'm only going to use from the x and forward. So I'm going to rewrite my equation to fill in my table. So it'll be y equals the square root of x. I always use 0, 1, 4, and 9 to fill in my x values. So I need to take the square root of 0, which is 0, the square root of 1, which is 1, the square root of 4, which is 2, and the square root of 9, which is 3. Okay? Go ahead and plot those points. So I have 0, 0, 1, 1, 4, 2, and 9, 3. Again, I'm going to make a dashed line because I have not taken care of my horizontal translation or my vertical translation. So from here, I need to move all these points to the right 2 and up 3. So I'm going to take this point, move it to the right 2 and up 3. 1, 2, 3. Take the next point, move it right 2. 1, 2, 1, 2, 3. Take the next point, right 2, up 3. And take my last point, right 2, and up 3. Now, this is my new starting point right here. I can make a solid line now because that is my actual graph. So I'm going to figure out what the coordinates are of my starting point, which is right 2 and up 3. So it is 2, 3, which means my domain is x is greater than or equal to 2, and y is greater than or equal to 3. Okay? On to problem number 3. I have f of x is equal to negative 1 times the square root of x plus 4. Remember from the beginning where I was explaining all the different transformations, if there is a negative out front, that instantly tells me that I'm going to have a reflection over the x-axis. Just write down reflection over the x-axis. You don't really have to think about what's going to happen to that, because it's going to get taken care of in our table. By filling in our table, it will go ahead and take care of all of those, the reflection, okay? So now the next thing I'm going to look for is anything underneath the square root sign. Well, I have a positive 4. Remember, I'm going to go opposite that sign, so I have a horizontal translation, left 4. I only want to use the information that's to the x and forward for my table, so y equals negative 1 times the square root of x. 0, 1, 4, 9, always for my x values. If I put 0 in for x, the square root of 0 is 0. 0 times negative 1 is 0. If I put 1 in for x, the square root of 1 is 1. 1 times negative 1 is negative 1. If I put 4 in for x, the square root of 4 is 2. 2 times negative 1 is negative 2. And if I put 9 in for x, the square root of 9 is 3. 3 times negative 1 is negative 3. Now we can go ahead and plot those points. I start at 0, 0. Then I go to positive 1, negative 1. Then I go to positive 4, negative 2. And then positive 9, negative 3. I do not want to make this a solid line because I have not taken care of my horizontal translation yet. Now, I need to go ahead and take care of my horizontal translation, so I'm going to move every piece to the left by 4. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. This I can now make a solid line. It should stay underneath of my original line. I need to find out what the coordinates of my origin point is, so it'll be negative 4, 0. So my domain, since my graph is moving to the right, my x's will still be greater than, because all the points to the right of our original point are larger than our original point. So it'll be x is greater than or equal to negative 4. But because my graph is going below the x-axis and it is moving in a downward fashion as I move to the right, my y is actually going to be less than or equal to the y value in my origin point, which is 0. Okay? That will not happen as often. It only happens when I reflect over the x-axis. Then my y will have to be less than. Okay? On to our last problem. So I have f of x equals 4 times the square root of x minus 3. Well, because this 4 is in front of our square root, that tells us that I will stretch my graph by a factor of 4. There is nothing underneath the square root sign, so I don't have a horizontal translation, but there is something on the outside of my square root, which is this negative 3. So I will have a vertical translation down 3. I don't have to worry about that for my table, though. I'm only going to look at what's underneath, or the x and forward. So I need to rewrite my equation. Y equals 4 times the square root of x. Remember, for my x values, it will be 0, 1, 2. Oh, I'm not sorry. It's not 2. It's 4. 1, 4, and 9. So now I need to take 0, plug it in for x. The square root of 0 is 0. 0 times 4 is also 0. Take 1, plug it in for x. The square root of 1 is 1. 1 times 4 is 4. Then I take 4, put it in for x. The square root of 4 is 2. 2 times 4 is 8. And then I put 9 in for x. The square root of 9 is 3. 3 times 4 is 12. Okay? I can go ahead and plot those points. So 0, 0, 1, 4, 4, 8, 1, 2, 3, 4, and 9. So 5, 6, 7, 8, 9. 12 will be the top of our graph. Remember, I do not want to make that a solid line because that is just my guideline. Now I need to translate. Use my vertical translation, which is down 3. So I go from this point down 3, this point down 3, this point down 3, and this point down 3. All the red dots I can make a solid line out of. I need to figure out what the coordinates of my origin point are. In this case, that will be 0, -3. Okay. Again, my graph is going up and to the right, so both of my x and my y in my domain, it will be x is greater than and y is greater than because it's going up and to the right. So my x is greater than my origin point x, which is 0, and my y is greater than or equal to my origin point, which is -3. Well, that is the end of our lesson. The most important thing here to remember is that for my table, every single time for my x values, I'm going to use 0, 1, 4, and 9 because they are the easiest numbers that I can use to take the square root of. Also, that if there is a number underneath of my square root, it is a horizontal translation, and I will go opposite. If there is a number behind my square root, it is a vertical translation, and I will follow the sign. Also, if there's a number in front of my square root, then that will stretch my graph by a factor of that number. And if there's a negative in front of my square root, it's going to reflect my graph over the x-axis. Remember, if you have any questions over this stuff, come on in and see me, either before school or ask me right when you come into class. Otherwise, thank you very much for watching the video, and have a great day.